Hello there, Algebras, and welcome to the Chapter 1, Lesson 3 notes video. So you can see I have quite a different background. This is, you see the cherries behind me, maybe even those plums up there. That means I'm videotaping from home. Okay, so the back corner of my dining room. All right, so what we're going to do real quick is we are going to go over our Chapter 1, Lesson 3, Solving Equations notes. So we're going to start to look at solving linear equations with these guys. Now, there's a few things that I need to bring back because I know that you're coming into algebra having solved equations. But what I also know is that there's a few pieces that now we want to explain a little bit more in depth about your equation solving that you've been doing and why we make some of the choices that we make on purpose when we're solving equations. Okay, so let's first start with the properties of equality. Now, chapter 1, lesson 2's video, the video you just did, that video talked all about properties of real numbers. So there were 10 properties that all real numbers had. I'm going to add two more properties of equality. Okay. The two properties of equality I'm going to add are the addition property of equality and the multiplication property of equality. Okay. So for the addition property of equality, what it states is that if you add a number to one side of the equal sign, you need to also add that number to the other side of the equal sign to balance it out. And notice this also works for if you're subtracting, because opposites, when you're subtracting something, you're really adding its opposite. That's actually what you're doing. So this falls under the adding category. Okay. All we're saying is if you choose to add something to one side of the equal sign, you better choose to add it to the other side as well. And that keeps the balance of everything on both sides of the equal sign. All right. Then there's the multiplication property of equality. It says pretty much the same thing, just involving multiplication or division. If you choose to multiply something by one side of the equal sign, you have to make sure you multiply it by the other side of the equal sign as well. Okay, so those things have to happen in that order. Hold on one second there, guys. I'm just gonna, whoop. Okay, I'm back, sorry. I just had to tell my husband to wake up my daughter. Oops. I want the other one. There we go. Watch. It is not going well. All right. I know you guys don't like it and woken up either. Well, neither does a toddler. Okay, so here we are. And we got done talking about our properties of equality. And that's actually what we use on purpose with our previous properties of real numbers. And we pick the right properties to use in conjunction with each other to force stuff to cancel from one side of the equal sign and then get down to less and less pieces that are involved and getting our x alone. So that's always the goal. So we're using these things to help us get our x value, whatever our variable is, usually x, alone in an equation. And what that does for us is then that gives us what's that real number value that x is equivalent to, right? So what we're going to do is we're going to show our steps. Whatever I do to one side of the equal sign, I have to show myself doing it on the other side of the equal sign too. So you're going to see me doing a lot of work. Okay. Today, what I'm also going to do is I am going to write little abbreviations of which properties I'm using each time I'm making a new step and solving my equation, getting my variable alone. Okay. And as I'm doing that, every single time I've done something, I'm going to rewrite my whole equation as what it looks like now. Okay, so it sounds like I'm going to be doing a lot of work, and I'm sure that this is all work that you have done and have looked at prior to now, but we're really just trying to put a lot of pieces together about how we know what the properties of real numbers say, we know what the properties of equality say, and now we're going to use those together to get an a variable alone and know what its value is, what its worth is. Okay? So, best way, of course, to go through this is practice. Let's start with practice problem number 1. And I'll zoom in now so you can see really the majority, the practice problem. Again, if I'm writing, you're writing. Okay? So you want to be writing down the exact same stuff I'm doing. Okay? So now, first thing I should notice is that my x is stuck in a fraction, right? It's the numerator in a fraction. It's up there. We've got a number that's being subtracted from that fraction, an equal sign, and a number on the other side of that equal sign. And so the first thing in my mind is, let's get this whole number away from this side of the equal sign. So right now, this whole number is a -2. In order to move it to the other side of the equal sign, I'm sure a bunch of you are yelling at the screen right now, add 2. Let's be specific. We add 2 to both sides. And here's the reason we choose to add 2. Because this -2 and this +2, when added up, they're additive inverses. And they add up to 0. So they've canceled each other out on this side of the equal sign. Now, the reason I need to do it to both sides is because I'm doing that balancing act, like we said, right? So we want to make sure whatever we're doing to one side of the equal sign, we're doing to the other. Okay? Now, what that does here is, like I said, we're rewriting each step. So we're going to bring down the x over 3 to the next line. There's nothing else here in the middle. We're going to bring down the equal sign, and then we're actually going to add these two numbers. Because, see, these two numbers we did add together, but they added up to 0. And we did that on purpose. We chose to add 2 because we knew that when added to -2, it's 0. And then I don't have to worry about that number being there anymore. Versus this other side, now these two numbers don't add up to 0. Actually, 4 plus 2 adds up to 6. Okay? So there's a reason we choose to add 2 to both sides of the equal sign, and that reason has to do with properties of real numbers. So like I said before, I want to talk about which properties I'm using as I go. I'm also going to write down abbreviations of those properties that I used. So the two properties I just used were the addition property of equality, the AE, I'm going to call it, right? Because I just used that. I just learned about that today. I did that adding 2 to both sides of the equal sign. But I chose to add 2. So I chose the additive inverse, and we'll call that guy the AI, the additive inverse. So I picked that number to do to both sides. Now I've got x over 3 equals 6. So now the only thing left and stuck with my x is this dividing by 3, right? So this is when you do kind of ask yourself, I mean, sometimes people get freaked out by fractions, but you just think about it. I have x divided by 3, right? And my answer is 6. What's the opposite of dividing by 3? It's multiplying by 3. It's the multiplicative inverse. Okay, if I multiply both sides by 3, and I'm showing multiplication using parentheses, right? Here, I've multiplied the top of this fraction by 3, and I'm dividing by 3. Well, what's 3 divided by 3, everyone? 3 divided by 3 is 1. That cancels out to a 1. And that means that all I've got left is 1x, which is exactly what my goal is to get my variable alone, just have one of my variable. So now over here, it's not going to cancel out. There's nothing being divided below, right? So I actually multiply those two numbers together, and 6 times 3 is 18. Okay? That's where I get that number from. So what two properties did I just use? Well, I used the multiplication property of equality because I chose whatever number I chose, I multiplied both sides by it. And then I used the multiplicative inverse because I said, well, the opposite of dividing by 3 was multiplying by 3. And that got me to my final answer, which is x equals 18. Okay. Let's do number 2. Okay, 30 equals 3 times y minus 9. So this time our variable is a y. We use the letters. They're in place of numbers that we just don't know the value of yet. And our goal in getting the letter alone is finding the value of that number, right? Whatever it may be. So this is where I can actually see, if I look at this side of my equal sign, I can see a piece of the distributive property here. I've got a number outside of a set of parentheses and addition or subtraction inside those parentheses. So what I do with that number is I actually distribute it by giving it by multiplication to both of my other numbers inside these parentheses, right? So we call that distributing. 3 times y is 3y. 3 times negative 9 is negative 27. Bring down this 30 because you didn't use it at all on this other side of the equal sign. And now I've got something that looks a lot more like the equation I started with last time. What property of real numbers did I use? The distributive property. Now I look, I've got this 30 on one side of the equal sign. I've got this negative 27 on the other side of the equal sign. They're both whole numbers. So let's get those together on one side of the equal sign. Let's get this 3y alone, right? So let's think what we were doing before. What's the opposite of negative 27? It's positive 27. That means if I add these two things up, negative 27 plus 27 is 0. So that's why I chose 27 to add to both sides. And again, I said both sides because I got to get it over here too. If you do something to one side of the equal sign, you have to do it to the other. So over here, we got 30 plus 27 adds up to 57. Bring down your equal sign and your 3y that did not get touched. Now notice these guys have canceled to 0, so they don't come down to the next line. They're taken care of, right? We say canceled because that part of the equation is gone over to the other side of the equal sign. And by moving it, right, that movement to the other side of the equal sign is what we're trying to do to get that y alone. Now let's look at what's attached to the y. A 3. How is that 3 attached to the y? By multiplication. Oh, sorry. I was trying to get ahead. Forgot my two operations that I used here were the addition property of equality that we just learned, right? I did it to both sides of the equal sign. What did I pick? I picked the additive inverse. That's what I did to both sides. Okay, now I'm back here where I'm multiplying the y by 3. I need to do the opposite to get the y alone. So I need the y to have this 3 gone, right? So the opposite of multiplying by 3 is dividing by 3. And notice, by the way, I show division as a fraction because fractions are just division problems. Okay, and so I show this in fraction form because it just makes it easier to cancel these guys out. 3 divided by 3 is a 1, and I'm left with a 1y here, which again, that's the goal. Get y alone, only one of them left. So I know what 1y is worth. Okay, so now, since I divided one side of the equal sign by 3, I have to divide the other side of the equal sign by 3. Anyone happen to know what 57 divided by 3 is off the top of their heads? No? Okay. How many times does 3 go into 5? Once, with 2 left over. How many times does 3 go into 27? 9 times. There you go. Y equals 19. So you just used the multiplication property of equality because whatever we did to both sides, or whatever we chose to multiply or divide by, we did it to both sides. And the thing we chose was the multiplicative inverse. The opposite of multiplying by 3 is dividing by 3. There you have it. So you're using these properties that we talked about just yesterday with our chapter 1, lesson 2 notes. We'll keep going. Another distributing one. This time potentially easier, maybe? I'm not really sure. I'm not sure what you see when you see this in front of a set of parentheses, because I see slightly easier, right? And the reason I say I see slightly easier than what we just looked at is because, well, there was a number 3 up there that I had to multiply everything by. This, I see a sign. And this is just like there's a kind of a hidden 1 right here. This is actually a negative 1 that I have to give by multiplication to both things that are inside the parentheses. So is the first thing I want to do. I want to kind of clear those parentheses out and use the numbers that should be there. So this -1 multiplies by both of these. Bring the x down to this line. Negative times 12, -1 times 12, -12. -1 times negative x, that's going to give me a positive x. Bring down the equal sign and the 38. And remember, we just used the distributive property, so I'll label that above. Okay. So now what we need to talk about is something called like terms that you're going to hear me say a lot throughout this year. But I'm looking for like terms on the same side of the equal sign to combine on that same side of the equal sign. When we have just numbers, it's a little bit easier sometimes to see those like terms, but variables are like each other too. If I've got an x here and an x here, it makes more sense to add those two together so I know how many total x's I have overall. So 1x plus 1x gives me that 2x that I've now combined into one set of them. Now bring down your -12 and your equal sign and your 38. Okay. We actually used two properties of real numbers when we did that there. Okay. By switching the order, we use the commutative property, and by grouping together, we use the associative property. So this was actually the commutative, and the associative properties that we used so that we could combine those like terms. Okay. If like terms happen to be already next to each other in your equation and you're just adding them up further, it's just the associative property. I had to do the commutative property because I had to switch their order and then combine. So I kind of used two properties at once. Now it looks like the stuff we've already done, right? What's the opposite of a -12? A +12. So I add 12 to both sides of the equal sign. So I'm using the addition property of equality as well as the additive inverse, right? Like I said, the opposite of -12, +12. These guys add up to 0, so they're gone. And that leaves me with just a 2x on this side of the equal sign. Bring down your equal sign, of course, to the next line. Add those two numbers up, 38 plus 12. You'll notice that I'm kind of doing this in my head, but I've been showing you guys how to add a little bit. So like 8 plus 2 is 0, right? So now I've got to carry the 1. 1 plus 3 is 4. 4 plus 1 is 5. So that's how I know, some of these quicker things that when I'm doing in my head. All right. I'm not trying to show off. I'm just trying to remind you of things that you learned a long time ago. All right. It's not as bad as you think. Now, how is the 2 attached to the x? It's attached by multiplication. What's the opposite of multiplying by 2? Divide by 2. So I just chose the multiplicative inverse, and if I'm going to divide both sides by 2, that's the multiplication property of equality. See, it starts to become a pattern, right? These for sure become a pattern of something that you just keep doing to get those variables alone. 2 divided by 2 is 1. That leaves me with the 1x that I want alone. 50 divided by 2 is 25, right? If you have 50 cents, divide that into 2 piles, 2 quarters. Another way to think of it. And of course, we are done. Might be a good place to stop if you need to kind of think. We're going to get into some slightly more challenging ones in a second. Okay? Pause. All right, move on. Number 4 is not slightly more challenging. I'm sorry. I guess I should have looked before I said that. Number 4 looks like I might need to use the distributive property, right? Because I see parentheses in the middle of my equation. I don't. Those parentheses are useless. They're not keeping my 15x and my 7. They're not keeping it held prisoner by something being multiplied by it, by this had a negative sign out in front of it. That's why we needed to distribute the negative sign. This has got nothing. So I can just bring the 15x and the positive 7 out, bring down the -12, the equal sign, and the 4. Now, remember what I said on the other side, right? If I have like terms next to each other already, I just group them together, add them up into one term, and that's the associative property. So here, my two numbers are already next to each other. So I don't need to use the commutative property to switch their order to get them next to each other. I'm just going to group them up. So what's 7 minus 12? -5, and bring everything else down. That, of course, is the associative property. I didn't write a property up here because I didn't use a property up here. I just took the parentheses away because they made no difference being there or not. There wasn't anything being multiplied on the outside of those parentheses. I didn't need them. All right, now let's move this 5 over to the other side of the equal sign, right? The opposite of a -5 is a +5. So I am using the the additive addition property of equality with the additive inverse because I chose to add 5 to both sides, right? -5, +5, add up to 0. 0. Left with 15x. 4 plus 5 over here is a 9. Cool. Okay, keep going. How is the x attached to the 15? Well, they're attached by multiplication. What's the opposite of multiplying by 15? Divide by 15. Okay, so I'm probably noticing the same thing you're noticing right now. You might be freaking out about it a lot more than I am because I'm not freaking out here. 15 divided by 15 is still a 1. 1x is left. Awesome. 9 does not evenly divide by 15. 9 is smaller than 15. I've got something that's not going to give me a whole number. Please don't freak out about that. There's a lot of things that happen in life that don't give you whole numbers as answers, and we have to be very used to that. Okay, so far, yeah, all my answers have been whole numbers, but I don't want you to get too comfortable only dealing with whole numbers. We talked already about real numbers, and that's what we're using this year. Decimals and fractions exist, and they exist for good reason. We need them to help us describe things that are going on around us. Okay? Well, in this case, what I'm going to do is I'm actually just going to simplify the fraction because I noticed already 9 is smaller than my denominator of 15. Okay, so I noticed that right away. So I'm not going to get a whole number that way. But I also noticed that 9 and 15 are both evenly divisible by 3. So what I can do is divide the top by 3, divide the bottom by 3, and I've got a simplified fraction. Okay? So 9 divided by 3 is what? 3, that's right. 15 divided by 3 is what? 5, that's right. 3/5 is my answer. X equals 3/5. That's the real number that makes this equation true. All right? What properties did I use at the end there? Same ones. Multiplication property of equality with the multiplicative inverse. The opposite of multiplying by 15 is dividing by 15. And that's what we did. Notice I said dividing by 15, right? I created a fraction as a division problem, and this time it really was a partial piece, right? Okay, so kind of putting some things together there. Not too bad, though. Sometimes fractions freak people out. That's why, number 1, just now with our answer on number 4, and then looking at number 5. But I really don't want you to get freaked out about them. I want you to think about the fact that they're just division problems, and the opposite of dividing is multiplying. And so that's, if you go into things that way, you can really easily get yourself out of a fraction too. If you don't like fractions, we can get ourselves out of them by knowing that if I multiply by my denominators, I'll get rid of them, right? So speaking of, let's look at these and find a common denominator, and let's multiply both sides by that. And I bet that'll help us out. Okay, so between these two, what could a 3 and a 6 both multiply to become? We call this a common denominator, right? That would be a 6. 3 can multiply by 2 to become a 6. 6 multiplies by 1 to stay a 6, the identity property. So that means that if I multiply both sides by 6, okay, and that's what I'm going to do. I'm going to do the easy side first, which is the right side. 6 divided by 6 cancels out to a 1, which is what I want, right? That side's done. So like I said, I did the easy side first. Over here, it's going to be a little more challenging because 6 divided by 3 is not 1. 6 divided by 3 is actually 2. So I divide 6 by 3, I get 2. But now I've still got this parentheses because that 2's got to multiply by both things in this numerator. So 2 times x is 2x. 2 times 2 is plus 4. Okay? Now, this is going to get a little tricky. Okay? We need all the x's on one side of the equal sign. So there's an x term here and an x term here. They're on different sides of the equal sign. I'm going to move my x terms just like I move number terms. Oh, sorry. I distributed over here. My bad. 2x, let's see. Right now it's positive. What's the opposite? So I can move it away. The opposite is a negative 2x. So I'm subtracting 2x from both sides of the equal sign. That's the addition property of equality. And I chose it to be negative 2x, so that's the additive inverse, right? So those cancel out to 0. That leaves me with a 4 right here. All right. Over here, x minus 2x is negative x, right? 1 minus 2 is negative 1. So negative 1x or just negative x, those are the same thing. Those are the same number. I've almost got x alone, right? What's that thing that's kind of stuck in front of the x? A negative 1, right? A negative 1. So if I just divide both sides by this negative 1, that gets me my x alone. Cancels it out. That's the multiplication property of equality with the multiplicative inverse. And 4 divided by negative 1 is negative 4. Now that negative had canceled over here to give us the positive x. See, we can't end on having a negative variable. We've got to know what a positive variable amount is worth. And one positive variable amount is worth. That's what we're trying to get to. And so that's why, even though I saw a negative x was 4, I'm like, I got to get that. What's regular x? What's x equal to? That's what I'm looking for when I'm doing these. All right. So I failed to mention something about this problem. When you have two fractions set equal to each other, that's called a proportion. And I picked a common denominator way to solve a proportion in this aspect. People really like to do this other way that you may or may not have heard of before called cross multiplying. So cross multiplying is another way to deal with a proportion. And that's how I'm going to deal with this proportion right after I go to the oven and get out whatever it is that is making that horrible noise that you can hear in the background. So hold on one sec. Okay, you'll hear it again in a moment. Needs a couple more minutes. But let's cross multiply till then, right? So in this proportion, I'm going to choose to cross multiply. And I'm going to show you why, because it's a little bit easier to handle it in this sense. Look, this denominator isn't a whole number, and I don't want to have to try and think about a common denominator that's got a variable in it, right? So instead, I'm going to try this trick where you take the bottom of your first fraction and you multiply it by the top of your second fraction. The bottom of this fraction times the top of this fraction. I'm just going to rewrite it in a form that will look familiar to you. Does that look familiar? I'm taking this number and I'm multiplying it by this whole number here. That whole number has got to be put in parentheses because there's a variable involved. Okay. Now, that's done. That's taken care of. I'm multiplying those two pieces together. So that's going to be one side of my equation now. And now I'm going to take this whole piece and multiply it by this whole piece. So the bottom of this fraction times the top of that fraction. I'm going to write it the same way because this guy's a whole number. So I'm going to keep him on the outside and put the variable on the inside. But I'm still multiplying these two pieces together. And so now, so that really was showing some distributing, right? So I'm going to keep that here because now I've got to actually do that distributing that I'm supposed to do. Okay. Now I will actually distribute. 4 times x is 4x. 4 times negative 7 is negative 28. Awesome. Bring down the equal sign. Actually distribute. 3 times x is 3x. 3 times 1 is plus 3. Okay, so now I've got variables on both sides of the equal sign. I've got numbers on both sides of the equal sign. When you've got that, it's actually going to be an easy thing. Okay, and I'm going to show it to you in steps, but I just want to show you that this is actually a good thing. Okay, because what you do is get all the variables, pick one side of the equal sign where you want all the variables to be, and pick that other side of the equal sign is where you want all the numbers to be. All right, and then that way you don't have to keep like flip-flopping all over the place. I like to keep my variables positive if I can. All right, so if I can move my variables to be together and keep a positive number of x's, that's what I kind of do. So I can see that I've got 4 x's over on the left side and I've got 3 x's over on the right side. So if I subtract 3x, I'm going to end up with a positive number of x's over here. So that's actually what I'm going to choose to do. So I'm going to choose my additive inverse to be negative 3x, and I'm going to, of course, add that to both sides. That's the addition property of equality. So my additive inverse is negative 3x, and I'm adding, I'm doing it to both sides of the equal sign, right? These guys cancel out to 0. These guys, 4x minus 3x is 1x, or just x. And now I'm going to bring down everything I haven't used yet. My negative 28, my equal sign, and my 3 on this side. 0 plus 3 is 3. So that's why I can just bring the 3 where it is, right? Okay, next. The opposite of a negative 28, because now that I've got all my variables over here, I'm saying, well, the numbers just go over there then. All right, variable club, numbers out there. So numbers, add 28. Add 28 to both sides, because negative 28 plus 28, that adds up to 0. That cancels out. Now over here, we're adding 28. Notice it's the same properties, again, that I'm using. I picked the opposite of negative 28 to add to both sides, and I'm doing it to both sides. And that's the addition property of equality, keeping things balanced, right? So I got x alone. And over here, I've got 3 plus 28 is 31. Wait a minute. Did I say I got x alone? I got x alone. I got 1x. So do I need to multiply or divide both sides by anything? Nope. I'm good. There you go. You're done. If you've got 1x, you're done. All right. Another time to like kind of sit back for a sec. Chill maybe. Okay. I was just going to say my oven's going to go off again. Okay. So there's our other time to chill. And I have to come back again, but I'll be back. Chicken cheddar broccoli bake is ready. I know you're going to start to ask your parents to make it for you because it sounds awesome and delicious, and it is. It is. It is. All right. We're on question 7. We're almost done here. I just see a few like decimals that we have to talk about. Right. I should probably find a graphing calculator so I can show you how to do that in a second, but wait a sec. All right. Let's see here. 3x equals 5x minus 28. Let's get all our x's on one side of the equal sign because the numbers have already decided that their club is over here, right? All the numbers are already over here, but I've got x's on both sides. And I need to have x's on one side only. And so we've already kind of said, well, this is numbers. So 5x, you got to go. What's the opposite of a positive 5x? A negative 5x. I'm going to subtract 5x from both sides. So I know I said earlier, sometimes I prefer to have positive number of x's, right? And that's what I usually, when I'm manipulating, I usually kind of try to do. But I can only have that choice when it's actually a choice. This place, there isn't that choice at all. You know, there's x's on both sides. They need to be on one side. There's numbers on one side. Numbers are staying right here. That's it. That's what's happening. Okay? So that's the addition property of equality along with the additive inverse. 3x's minus 5x's is negative 2x's. Bring down your equal sign. Your 5x and negative 5x has, of course, canceled out to 0. And bring down your negative 28, right? All right, so next, how is the negative 2 attached to the x? By multiplication. What is the opposite of multiplying by negative 2? Dividing by negative 2, right? Negative 2 divided by itself is 1x, which is what I want, just an x left. And negative 28 divided by negative 2. Negative divided by negative, guys. Nate, negative divided by negative.
Positive.
Thank you. See that? Even he knows. He hasn't taken algebra in what, 25 years?
Yeah, it could be. Also help it is valid in multiplication.
True. All right. While we were talking about that, I, of course, wrote down that we use the multiplication property of equality because we divided both sides of the equal sign by negative 2. And 8. Quit it. And the multiplicative inverse, of course, because the opposite of multiplying by negative 2 is dividing by negative 2. All right. We'll keep going. Here we go. This is my cat, Isis. Say hi to everyone. Any chance you want to take her? Okay, I can deal with her tail. All right, here we go. Decimals. Please do not be intimidated by decimals. They're just parts of whole numbers. They're still rational numbers, so at least they're not irrational, right? Okay, so we need to get all of our x's on one side of the equal sign. We need to get all of our numbers on the other side of the equal sign. So here is where I'll stick to what I said earlier. I like to have positive x's, and I'll subtract these. So I'm thinking in my head right now. Now, obviously, in real life, I won't be doing this, but in my head, I'm kind of ignoring my decimals on these. And I'm thinking I've got a 3x and a 4x, right? And so see, because I can do that because they're in the same spot behind the decimal, so I can kind of treat them that way. All right. So that's what I'm going to do is I'm going to use the additive inverse on this. They cancel out to a 0. Bring down your negative 12. And here, let's see. Let's just think about it like I was saying before. 4x minus 3x is 1x, right? So keep that decimal point in place, and you've got 0.1x, okay? Now, bring down your plus 8, and we can see already that we are going to need to move that 8 by subtracting it from both sides. The opposite of a positive 8 is a negative 8, so let's subtract it. 8 minus 8 cancels out to a 0. And negative 12 minus 8 over here is a negative 20 over here. So bring all this down, right? So we just use the additive inverse and the addition property of equality twice in a row. All right, that's what we were just doing. So I don't have a graphing calculator down here right this moment, so I'm just going to show you using my phone calculator because, well, sometimes that's life. They haven't put my emulator on my computer yet either, so I don't have my emulator on. It is what it is, right? So what I'm going to show you right now is that when you divide by a decimal, value of your other side is going to increase. Okay, so let me just show you. In this case, I need to, the opposite of multiplying by 0.1 is dividing by 0.1. So that's what I'm going to do to both sides to get x all by itself. So negative 20 divided by 0.1 equals. And I say, in this case, it's negative, so the value has decreased. But we have a bigger number now when we had that dividing by 0.1. And by how much? one whole number place value because I divided by one decimal place value. Okay. I'm just trying to show you where these numbers come from as we're talking about it. And of course, this was the multiplication property of equality with the multiplicative inverse. Okay, we're almost there, guys. I'll keep that. We'll want it for this guy down here just to show that again, right? But really, decimals were not any harder. We lined them up. Isis is staring into this video camera, and it's hilarious.
Yep. How much longer?
I got 2 more questions. Okay. So number 9, you'll notice that I've got variables on the same side of the equal sign that need to be combined. So I'm going to use the commutative property to put them next to each other in my head. Then I'm going to use the associative property to actually combine them. All right? Maybe my hand will help. There it goes. All right, so there's the like terms that I'm going to combine, right? And the associative property and the commutative property. 6x minus 3x is 3x. Bring down the plus 7, the equal sign, and the negative 8. Okay, numbers relegated to the other side. There they go. What's the opposite of a positive 7? A negative 7. You do start to get into a groove once you get going. Probably remember a lot of this stuff, right? Of course, negative 7 is the additive inverse of a positive 7, right? And I subtracted that 7 from both sides of the equal sign, so that's my addition property of equality. I am bringing down the 3x, the equal sign, and negative 8 minus 7 is negative 15. Okay, last thing to do to get x alone, divide both sides by 3. The opposite of multiplying by 3 is dividing by 3. 3 divided by 3 cancels out to a 1x, which is what I want. And negative 15 divided by 3 is a negative 5. Let me get my properties up there. Then I can box my answer in. There we go. Doing well. Last one. Okay. Numbers on both sides. X's on both sides. I'm just going to keep the X's on the left. I'm not even going to. You can think of this as 12 and 14, though, right? Because, again, place value-wise, right? Place value-wise, you can think of it that way. Cancels out. Right? So this is the addition property of equality with the additive inverse. I'll do it in 2 steps this time, right? So let's see. I'm subtracting. So what's 12 minus 14, guys? That would be negative 2, right? But where is that 2 going to be? It's going to be here. So it's going to be 0.02. And there's x because x was attached, right? And it's negative because the 14 was bigger than the 12. So that's what's left. Bring down the minus 0.5, the equal sign, and the negative 0.9. Okay. Now let's add that 0.5 to both sides because the opposite of a negative 0.5 is a positive 0.5. So addition property of equality with the additive inverse again. They cancel out to 0. Yeah, because even fractions and decimals, they have opposites too, right? So they have opposites just like all of our whole numbers have opposites. And that's what makes up the rational numbers. So that's what's kind of nice, right? So I get negative 0.02x equals, well, you can think of this as negative 9 plus 5. You're going to get a negative 0.4. And now we need to get x alone, and x is currently multiplied by 0.02. So let's divide by both sides by negative 0.02. I meant to say negative, I'm sorry. And that is important. And the reason I say that's important is because negative divided by negative leaves me with this positive 1x, right? So that's why you have to make sure it's the negative 0.02 that you're dividing by. But also over here, it's a negative 0.4 divided by negative 0.02. So the sign is, again, important, right? So it was 0.4, negative 0.4 divided by 0.02, and it's a negative 0.02. And it's going to give me a positive answer, and that answer is positive 20. Again, I like to show you guys kind of that, like where some of those things come from when we're doing this first one. There was a lot of examples to do. Solving equations is really important. I mean, that is algebra, that we have been doing algebra, right? But we need to get more in depth with this algebra this year. So we've got to have the basis first. So please make sure if you need more help with your homework practice problems that you watch the video again while you're doing your practices. You have these practices that you did with me ready to go as you're going, right? And you ask for help if you need it. Okay? So there it was, chapter 1, lesson 3 notes. Good luck, guys, and I will be seeing you soon.